Hello, this is Mrs. Scarple, and in this video I am going to cover um, finding the mean. The median we have talked about if you watch the video on the 5-number summary, but we will also do that here. The deviation from the mean and the absolute deviation from the mean, or the absolute deviation, so that we can find the mean absolute deviation, also known as MAD. So to find the mean just means average. You probably remember learning how to find an average. Well, the statistical term for it is mean, and that's when you add up your set of numbers and divide by the number of numbers. So if I pull up my calculator here, we're going to add 60, 65, 71, 59, 68, 65, 70, and 66, for a total of 524. We're now going to take that number and divide it by 1, 2, 3, 4, 5, 6, 7, 8. Now in our graphing calculators, if I press divide by, is going to set that 524 as my previous answer, divided by, I believe I said 8, 2, 4, 6, 8. Yes, I did. So I'm going to get a 65.5 as my mean. And I'm going to write that number in every cell here. 65.5, 65.5, 65.5. And the reason we're doing this is because we have to find how far away is the number within the set from the mean of the set. So we're going to have to do some subtracting. So we're going to find that deviation. That means I'm going to take my original data value and subtract the mean. So let's get my calculator again. I'm going to clear my window here. And I'm going to do, oops, did not mean to lose my calculator. There we go. I'm going to take 60 minus 65.5. And we have negative 5.5. And then we have 65 minus 65.5 is negative 0.5. 71 minus 65.5 is 5.5. 59 minus 65.5 is negative 6.5. 68 minus 65.5 is 2.5. We have another 65 minus 65.5, that's negative 0.5. 70 minus 65.5 is 4.5. And then we have 66 minus 65.5, that's just 0.5. Now, the absolute deviation means the absolute value of each of these numbers. Absolute value is how far away is the number from 0. And since we're talking about a distance, the absolute deviation, or the absolute value of our deviation, is always going to be positive. So negative 5.5 becomes a positive 5.5. Negative 0.5 becomes a positive 0.5. If it's already positive, it stays positive. Negative 6.5 is now positive 6.5. I believe that should be 2.5. Kind of looked like a 25 for a second. And then again, we're going to have a positive 0.5, 4.5, and 0.5. So we found the mean, which is 65.5, by adding all of these data values and dividing by 8. Now for the mean absolute deviation, we're going to find the mean of this last column. So I'm going to take my calculator again. I'm going to slide it over so I can see those numbers. I'm going to clear my calculator, so I'm going to add 5.5 to 0.5 to another 5.5, 6.5. Oops, I'm not adding any of these. Let's clear the calculator and start over. 5.5 plus 0.5 plus 5.5 plus 6.5 plus 2.5 plus 0.5 plus 4.5 plus 0.5. And let's see where my error is. Oh, I have a double plus. Let's get rid of that. And now let's see if it works. And we have 26. Now I need to divide 26 by 8 because we have a total of 8 data values to start with. So we have 8 deviations. So 26 divided by 8. I think I have a mistake somewhere. That number seems a little bit higher. So I'm going to try this one more time, and if I get the same answer, then that is the correct answer. So let me just clear again. 5.5 plus 0.5 plus 5.5 plus 6.5 plus 2.5 plus 0.5 plus 4.5 plus 0.5. Oh, I got the 26 and divide by 8. And we have 3.25. So that gives us a mean absolute deviation of 3.25. Again, that is the average, or you find the total of all of these deviations and divide by the number of them. And just a reminder, median is when you take your numbers and you write them in order. So our smallest number is 59. And then we have 60. And then the next one looks to be, the next two would be 65. And there's a 66, a 68, a 70, and a 71. Now we should have 8 numbers here. 1, 2, 3, 4, 5, 6, 7, 8. And when I split 8 numbers into 2 groups, that puts me halfway between 65 and 66. So my median is 65.5. So in this case, my median is the same as my mean. These are both measures of center, and in this data set, these would be good numbers to use to describe the typical value in our data set.